Welcome back. We are going to look at our last lesson for test 3. And test 3 is going to be over chapter 5 and then 6.1 and 6.2. And 6.2 are a few more identities surrounding the trig identities. These are dealing with the sum and difference identities. So they're summarized for sine, cosine, and tangent. All on the first page of the lesson 6.2. Again, I suggest writing those on your note sheet to be used on the exam. They're not on the sheet that I'm giving you. Then they do give some cofunction identities as well on page 516 in your book. So some cofunction. And then also the sum of sines and cosines function. And I think those are the three main ideas. Yeah. So let's jump into some problems using the identities that we've learned about. So question number 9 says, find the exact value of each expression. So 9, 11, 15, and 17 are all in this find the exact expression piece. So I'm going to go ahead and show you my paper for that. Let's start with number 9 here. So we're finding the exact value of the sine at pi is 1. I'm sorry, it's 0. Sine at pi over 3. You can use your little sheet if you've been making that. Sine at pi is 0. Sine at pi over 3 is square root of 3 over 2. But that doesn't matter because 0 times anything is 0. Number 11 is also with sine. So sine of negative pi over 3. So at negative pi over 3, sine is negative in the fourth quadrant. So this is a negative square root of 3 over 2. And then sine at pi over 3 is square root of 3 over 2. So this is going to be a negative square root of 9 over 4. And then that simplifies to a negative 3/4. Number 15, 17. So 15, now we're going by degrees instead of radians. So sine at a negative 45 is going to be in the fourth quarter. So it'll be negative a negative square root of 2 over 2 times cosine at 30 degrees. So cosine at 30 is a square root of 3 over 2. So this multiplies to make a negative square root of 6 over 4. And then 17 is kind of working us into the sum identities, because you can tell these are cosine and sine here, and this is going to be the sum identity for cosine. You can see the way it's written here. So cosine at pi is a negative 1 times the cosine at pi over 3 is 1/3. I'm sorry, 1/2. I read that wrong. 1/2. And then we're going to add that with the sine at pi is 0. Sine at pi over 3 doesn't really matter, but it's square root of 3 over 2. So we end up with a negative 1/2 plus 0, and that results in a negative 1/2. Okay, so let's get us warmed up here. So I wrote number 21 out because I wanted you to see how this is going to work. So 21 says 21 through 38, all of these problems is saying find the exact value of sine, cosine, and tangent of each angle. And so essentially they got this one started for us. They said they want 11 pi over 12, and that's going to break into 2 pi over 3 plus pi over 4. And if you had common denominators, this would be 8 pi over 12 plus 3, plus yeah, 3 pi over 12. So they're simplified here. So sine the sum identity for sine is the sine of A times the cosine of B. So the sine of A times the cosine of B plus the cosine of A times the sine of B. So we're going to go through and find these. So 2 pi over 3 is in the second quadrant. So sine in the second quadrant of pi over 3 is a positive square root of 3 over 2 times the cosine of pi over 4 is the square root of 2 over 2 plus the cosine at 2 pi over 3. So cosine in the second quadrant is now negative. And that's 1/2. And then sine at pi over 4 is square root of 2 over 2. So this simplifies into square root of 6 over 4 plus the square root of 2 over 4. Then the sum identity for cosine is cosine of A times cosine of B minus sine of A times sine of B. And so we already know these values. Cosine of 2 pi over 3 is 1/2 times the cosine of pi over 4, which is square root of 2 over 2. Subtracting, did I do this? Yes. The sine of 2 pi over 3 is square root of 3 over 2 times the sine of pi over 4, which is square root of 2 over 2. So this is the square root of 2 over 4, subtracting the square root of 6. And then tangent is a ratio. So the tangent of 2 pi over 3, so tangent in the second quadrant is a negative because cosine is negative. So it's a negative square root of 3 plus tangent of pi over 4 is 1 over 1 minus tangent of 2 pi over 3. So square root of 3 times tangent of pi over 4 is 1. So this becomes negative square root of 3 plus 1 over 1 minus the square root of 3. And the numerator can be rewritten as 1 minus the square root of 3 over 1 minus the square root of 3, and that simplifies to 1. So this section is expecting you to find the sine, cosine, and tangent of each of these. Okay. So next up is negative 13 pi over 12. So the common radian measures that we have, none of them are over 12. So let's simplify this into something that could be over 6. So 11 and 2, no, won't reduce over 6. What about 10 and 3? So negative 10 pi over 12 minus 3 pi over 12. And those simplify into a negative 5 pi over 6. And then negative pi over 4. So the sine of this is going to be the sine of a negative 5 pi over 6 times the cosine of a negative pi over 4 plus cosine of a negative 5 pi over 6 times, the sine of a negative pi over 4. So sine at a negative pi over 6, sine is negative. Pi over 6 is a negative 1/2. Cosine at a negative pi over 4 is positive there. And that's a square root of 2 over 2. Okay. Plus cosine at negative pi over 6. Cosine is negative in the third quadrant. So pi over 6. Cosine is square root of 3 over 2. And sine the negative pi over 4. So sine is negative in that fourth quadrant. And pi over 4 is square root of 2 over 2. Okay. So this becomes a negative square root of 2 over 4 plus the square root of 6 over 4. Or you could write that as the square root of 6 subtracting the square root of 2 over 4. Cosine then, this is sum of, it's a sum. And so this is going to be cosine A. So cosine of a negative 5 pi over 6 times cosine of a negative pi over 4, subtracting sine of a negative 5 pi over 6 times sine of a negative 5, just a negative pi over 4. Okay, so cosine at negative 5 pi over 6, I can just use my pieces from up here, is the square root of 3 over 2. Cosine at negative pi over 4 is a square root of 2 over 2, subtracting sine at the negative 5 pi over 6 is the negative 1 half. And sine at negative pi over 4 is square root of 2 over 2. So this becomes square root of 6. That's a negative times a negative. So it's a positive square root of 2 all over 4. So that is similar to the one that we had up here in 21. The sine. Okay, tangent. Tangent, let's go back to this again so make sure we get it right. Tangent of a sum is tangent of A plus tangent of B. So tangent of a negative 5 pi over 6 plus tangent of a negative pi over 4 all over 1 minus the product. So okay, so now we have to go to our table here, tangent of these values. So tangent at negative 5 pi over 6. They're both negative in the third quadrant. So their tangent is positive. Tangent is square root of 3 over 3 there. It's going to be 1 minus, and then I'm going to use it down here too, square root of 3 over 3. And then tangent of a negative pi over 4. So they're opposite signs in the fourth quadrant. So tangent is negative in the fourth quadrant. And that's 1 at pi over 4. So 1. So this is the square root of 3 plus 3 over 3 when I get a common denominator. And that's a 1 there. So then this is 1. So then this is going to be 1 minus the square root of 3 over 3. And they're opposite signs, so it can't simplify anymore. This definitely takes some more work because you have to use the formula. Make sure again that you're putting the basic identities, the sum and difference identities, the co-function identities here, and the sum of sine and cosine, all of that on your note sheet for sure. Okay, 35 is wanting us to find the sine, cosine, and tangent, and the degree is 105 degrees. 105 degrees. So we can break that into a sum of 60 degrees plus 45. So the sine of 105 can be the sum, so it'll be sine of 60 times cosine of 45 plus cosine of 60 times, sine of 45. Sine at 60 is square root of 3 over 2 times cosine of 45 is square root of 2 over 2 plus cosine at 60 is 1/2 and sine at 45 is square root of 2 over 2. So we end up with the square root of 6 plus the square root of 2 over 4. It's common values here from what we've been seeing. Okay, using the sum identity for cosine, we get cosine of 60 times cosine of 45, subtracting sine of 60 times sine of 45. And so cosine at 60 is 1/2 times cosine at 45 is square root of 2 over 2, subtracting sine at 60 times sine at 45. So this becomes, simplifies into square root of 2 minus square root of 6 over 4. And then the tangent of 105 is this quirky formula that we've been working with here. So the tangent of A plus the tangent of B, the tangent of 60 plus tangent of 45 over 1 minus the tangent of 60 times the tangent of 45. Tangent of 60 is square root of 3 plus tangent at 45 is 1 over 1 minus tangent of 60 square root of 3 times 1. So we end up with 1 plus the square root of 3. I just like to put that first over 1 minus the square root of 3. Okay. So number 39, they're asking us to verify the co-identity. So this is the co-identity for cosine. The cosine of pi over 2 subtracting a is equal to the sine of a. And they want us to verify this. So we're going to use the difference identity to do that for cosine. The difference identity for cosine is cosine A, cosine B plus sine A, sine B. So cosine pi over 2 times cosine of A plus sine of pi over 2 times sine of A. Cosine of pi over 2 is 0. So that's going to make this go to 0 plus, okay, and then sine of pi over 2 is 1 times the sine of A. So this is just going to be 0 times the sine of A is the sine of A. That wasn't too bad. So we just used our difference identity to do that. Okay. 43 and 45 are asking us to find the exact value of each function. They're giving us that it's in the fourth quadrant. Sine is a negative 305. The sine of A is a negative 3/5, and the cosine of B is 5/13. So they want us to find the sum of this. So let's just take a minute and do that. Before I move on to 43, I want to go back and look at something that I just checked when I was doing the sum identities. For the sum identity on 21, I said this tangent of 2 pi over 3 was a negative square root of 3, so this should have been a negative in here. That would have made that a positive. So the answer would be 1 minus the square root of 3 over 1 plus the square root of 3. So I apologize for that. Okay, so we're at number 43. We're looking at the cosine of A plus B, where we're in the quadrant 4. And these are the values. So the sum difference says the cosine of A times the cosine of B minus the sine of A times the sine of B. Okay, so the cosine of A, we don't have, we have the cosine of B is 5/13 minus the sine of A we have is a negative 3/5. And we don't have the sine of B. Okay, but because we do know this is in the fourth quadrant, and let's draw this angle here, this angle here, we know that sine is a negative 3 and the hypotenuse is 5. So this must be a 3, 4, 5 triangle. Calculator here. Okay, so this is going to be the square root of 5 squared minus negative 3 squared. So that's going to be a 4. So the angle is in the fourth quadrant, so cosine is positive. So the cosine of A will be 4/5. And then the sine of B, so I think this is going to be a 5, 12, and 13 angle. Again, this one is also in the fourth quadrant. And the hypotenuse is 3 and cosine is 5. And so we're going to have the square root of 13 squared minus 5 squared. And that is 12. So that means sine in the fourth quadrant is a negative 12/13. So we have these 5's cancel, and we have 4/13. negative times a negative times a negative is still a negative. And that's going to be 36 over 65. And we can do some canceling, or maybe not. 4 divided by 13. Subtracting 36 divided by 65 is that, I'm going to try to, oops. Oh gosh. There we go. Is it negative 16 over 65? Cosine of A. Oh, this should be cosine of 13. Cosine should be, no, 4 over 5 is cosine of A, 4 over 5. And then cosine of B is 5 over 13, so those cancel. And then this would be the sine of A is another 3 over 5. And then the sine, oh, the sine of B, yep, 12 over 13. That would be negative 32. Okay. Number 45. Using the same values, the tangent, identity for tangent is the tangent of A so tangent of A is the opposite over the adjacent, so negative 3/4 plus the tangent of B, so that would be 12/5 over 1 minus tangent of A is that, tangent of B is that, tangent of A is the negative 3/4 times the tangent of B. Okay. And so we have, if we get a common denominator of 20, we have a negative 15 plus 48 over 20. So that would be 33 over 20 and then numerator. And that's going to be 1 minus, only 1 plus 36 over 20. So if we add that, that's 56 over 20. So this is 33 over 20 multiplied by 20 over 56. And 33 over 56. No, I did this one right column floor. Okay. Okay, so number 49 is giving us a stipulation as well, 49 and 50, 49. It's saying we're in quadrant 2, and the sine of A is 1/3, and the cosine of B is a -1/4. So first of all, before we can use the difference identity for this cosine, we have to find our other measures. So let's first do this angle. It's in the second quadrant here. And so if A is, the sine of A is 1/3, then this is going to be the square root of 9 minus 1, so the square root of 8. So this is going to be -2 the square root of 2. And then for the third side, and then this angle in the second quadrant, cosine is a -1/4. So this one is going to be the square root of 4 squared minus -1 squared. And so that is the square root of 5. 15, the square root of 15. So this is the square root of 15. Okay, so to find the difference of A minus B of cosine, then we're doing cosine of A, let's just write it out, cosine of A times the cosine of B, and make sure I'm doing it right, plus sine of A times the sine of B. So cosine of A here is going to be the adjacent over the hypotenuse. So -2 square root of 2 over 3 times the cosine of B, which we know is a -1/4, plus the sine of A, we already know is 1/3, times the sine of B, which is going to be the square root of 15 over 4. So we multiply those, we get 2 times the square root of 2 over 12. And common denominator, so we end up with 2 times the square root of 2 plus the square root of 15 over 12 for 49. Okay, so let's look at number 55. 55 says write each function in the form of c times the sine of x plus theta, where theta has to be between 0 and 2 pi. So we have f of x square root of 2 times 2 sine of x plus the square root of 2 times over 2 cosine of x. So we could pull that out front, square root of 2 over 2, and then we've got the sine of x plus the cosine of x. And we want to write this as the form of sine of the x plus theta. So let's go to where we show this in the book here. And we're going to writing it as a sum of sine and cosine. So we're using this piece right here. Okay, so when we look at this, we're looking at A is a coefficient on sine of x plus B is the coefficient on cosine of x is equal to C, the coefficient on the single function of sine of the sum identity. And that's where our cosine of the angle, the theta that we're coming up with, is the ratio of A to C, and the sine of that same angle is the ratio of B to C. So that means when we look at ours, let me go back to my paper. When we go back to ours, they share the square root of 2 over 2. And they're both the square root of 2 over 2 at pi over 4. So that is our angle. So our angle is equal to pi over 4. So we can write this as the sine of, because 55 says, write each function in the form of, so this, when we write these as a ratio, that ratio of square root of 2 over 2 over the square root of 2 over 2 is 1. So it's just 1 times the sine of, and they want it in this form of x plus theta. So it's of x plus pi over 4. Okay. Then number 61, the last one, says write in terms of a single trig function of just x. So we have sine of x minus pi for 61. And we know that x minus pi can be written as just the negative of the sine of x, because sine of pi is 0. And so we can write it with a negative. Because this can be written as sine of pi minus x and then when we do that, the sine of pi is 0. So we know the sine of a negative x is the same as a negative sine of x. So 6.2 is a little more challenging. The majority of the exam is going to be over chapter 5 and 6.1. I want you to be able to put these sum functions, the sum identities together, but the majority, like I said, is going to be over chapter 5 and 6.1.